Hello everyone, engineering statistics and linear algebra. In last video, a bivariate transformation concepts were discussed. Today we do highlight it for a while. Consider two equations where x, y, u and v are different random variables. Random variables u and v are defined in terms of x and y. It is called as a bivariate transformation here. Mu u, mu x and mu y, they are called as a mean of a random variable u, x and y respectively. Mu u, mu v is called as a mean of a random variable v. These two equations are obtained by applying expectations on both sides. These concepts were discussed in the last video. It is called as a variance of u, denoted as sigma u square. That can be calculated if we know variance of x, variance of y, covariance of xy, where a, b are the constant from the first equation. Variance of v can be calculated again if you know variance of x, variance of y, covariance of x and y, where c and d are the constant from the equation number 2. Similar to this covariance of x and y, we can calculate covariance of u and v using this formula, where a, b, c and d are the constant from these equations. All these equations are derived in the last video. You please refer them. Based on this concept, today we do solve some more problems. Consider a problem here. The variance of the zero mean random variables x and y are given as 7.05 and 5.36 respectively. Also given that the correlation coefficient for x and y is rho xy equals to minus 0.48. A bivariate random variables u and v are obtained with the transformation u is equals to 2x plus y, v is equals to x plus 2y. Find correlation coefficient rho of random variables u and v. Alright, let us write given data. Variance of x, it is denoted as sigma x square, that is equals to 7.05. Variance of y 5.36. You can observe here correlation coefficient for x and y is given here, that can be written here, and they have asked us to calculate a correlation coefficient of u and v, and also a is 2, b is 1, c is 1, d is 2. A correlation coefficient of u and v can be calculated if we know covariance of u and v divided by standard deviation of u and standard deviation of v. Alright, covariance of v can be calculated using this formula, already we have discussed. Now if we know variance of v, then we can calculate a standard deviation of v. Variance of v can be calculated using this formula. To calculate a standard deviation of u, variance should be known. That variance can be calculated using this formula. Okay, the first calculation is a calculation of covariance of x. In all these three equations, covariance of xy is necessary here. Let us calculate covariance of xy here. Covariance of xy can be calculated using a correlation coefficient formula. Correlation coefficient formula equals to covariance divided by standard deviation of x and y. You can observe from the given data all these three given, so that we can calculate covariance of xy here. Substitute. They have given a variance, but here it is standard deviation. so that square root of variance gives a standard deviation. Square root of 7.05, square root of 5.36, and correlation coefficient is given here minus 0.48. After calculation, covariance of xy is calculated here minus 2.9505. All right. Next, let us recalculate variance of u. Let us recalculate variance of u using this formula. So variance of x is known, variance of y is known, and covariance of xi is just calculated. And substitute a and b values here. You can observe here a is 2, b is 1. Substitute all the values properly and do the simplification. We will get a variance of u. However, calculation of a variance of v, this formula can be used. Instead of a and b, here c and d constants are used here. C is equals to 1, d is equals to 2. Covariance of xi is just now calculated. Variance of x and y, they are already given in the data. Substitute all the values, do the simplification properly, then a variance of v is 16.6872. All right. Next is a covariance of u and v. It can be calculated using this formula. Variance of x is known, covariance of xy is calculated, variance of y is known, and the constant a, b, c and d are given in this formula. Substitute all the values, do the simplification, and we will get that value as 10.0665. They have asked us to calculate correlation coefficient of random variables u and v. That can be calculated if we know a covariance of u and v and a standard deviation of u and v. It is calculated here 10.0665. Actually, we have calculated a variance of u and v, but here in the formula standard deviation is there. So that takes square root of those two. Do the simplification, we will get correlation coefficient of u and v is 0.5283. It always varies from plus or minus 1. All right. Let us consider the one more problem here. A bivalent transformation. In the place of a, b and c, d, the constants are different here. A is cos theta, b is minus sin theta, c is sin theta, and d is cos theta. So using Cramer's rule, we can get the values of x and y here. These two equations can be represented in matrix form, and values of x and y can be calculated using Cramer's rule here. So for the calculation of x and y, a determinant of this matrix is needed. So determinant of this matrix is 1, cos into cos, cos square, minus into minus plus, sin into sin, sin square. Answer of this is 1. The value of x can be calculated by replacing first column by u and v by keeping the second column as it is divided by the determinant. Do the multiplication, u into cos theta, minus into minus plus, v into sin theta. Similarly, y can be calculated by replacing the second column by this u and v. Do the simplification, cos theta into v, v into cos theta, minus u into sin theta divided by 1. So that from given u and v, we have calculated x and y here. All right. Let us calculate mean of x and y. For those two formulas, Let us apply expectations on both sides. X becomes mu x, cos theta is a constant, u becomes mu u. Sin theta is a constant here, expectation of v becomes mu v. Similarly, a mean of y is calculated here. A variance of x. The formula for variance of x is what? A square variance of u plus 2 into ab covariance of u and v plus b square into variance of v. Already we have discussed here. Here only the random variables are interchanged, nothing more than that here. And a is cos theta, a is cos theta, a square is cos square theta. Substitute 2 into a into b, all right. B square is sin theta, sin square theta. Then a variance of y can be calculated using this formula. Substitute the values of c and d from this equation. C is nothing but minus sin theta, square of it is sin square theta. Next, c into d, sin theta into cos theta multiplied with 2 and minus sin. Similarly, d square cos square theta. All right. We have calculated variance of x, variance of y, then covariance of xy that can be calculated using this formula. So substitute a and c. A is cos theta, c is minus sin theta into cos theta, plus b into c, sin theta minus sin theta minus sin square theta, plus a into d, cos theta into cos theta, plus b into d, sin theta into cos theta. All right. Then do a simplification here. From these two first and the last terms, sin theta and cos theta are the constants taken outside. The remaining terms are variance of u minus variance of v, and this term is kept as it is. Using those two formulas, let us solve one problem here. A xy they are given, and covariance of xy is 0. What is the meaning of it? X and y are uncorrelated. If covariance of xy is 0, then we can say that x and y's are uncorrelated. And mu of u, mu of v, variance of u, variance of v, and covariance of u and v, if they all are known things, and covariance of xy is 0, then using these two formulas, then we can calculate the value of theta here. So covariance of xy, it is already calculated here in the previous slide. And what we have assumed here, x and y random variables are uncorrelated. If they are uncorrelated, then covariance of xy is 0. That is the property of a random variable that is discussed. And substitute cos square theta minus sin square theta is equals to cos of 2 theta in this place. 2 into sin theta into cos theta is equals to sin of 2 theta. It is replaced by sin 2 theta divided by 2. Okay. Next, do the simplification here. So move this term to the LHS side so that it can be written as variance of u square, variance of u minus variance of v. Next, cross multiplication, 2 into covariance of u and v divided by this term. It can be replaced by tan of 2 theta. tan of 2 theta is equals to 2 into covariance of u into v divided by variance of u minus variance of v. These are the three formulas that should be known. This formula and the previous slides formulas should be known to calculate uh, values of theta and variance of x and variance of y. All right. Based on these formulas, let us solve one problem here. Mean of u, mean of v, they are 0. Variance of u is given, it is 1. Variance of v is given, it is 7. And they have said that x and y are uncorrelated. If they are uncorrelated, covariance of xy is 0. And also they have given covariance coefficient of u and v is minus 0.30. Then they have asked us to calculate covariance of u and v, theta, next variance of x and variance of y. To calculate covariance of u and v, this formula is needed here. You can observe from the given data, it can be easily calculated here because this is known. Standard deviations can be calculated from the given variance. Square root of variance gives a standard deviation. So that first term can be calculated very easily here. So covariance of u and v equals to, do the simplification, the answer is minus 0.794. How to calculate theta? It can be calculated using this formula. Two theta is equals to tan inverse of all those things. Covariance of uv is just now calculated. All these terms are known. Substitute and do the simplification. Theta is 7.4097 degrees. All right. They have asked us to calculate a variance of x. That can be calculated using this formula. Then cos square theta is calculated here. 2 into sin theta into cos theta. Covariance of uv is also calculated. All are known terms here. Substitute all the terms with the theta value as 7.4097. Do the simplification. Then we'll get a variance of x as 0.8968. The last calculation, variance of y. It can be calculated using this formula. Sin square theta is calculated already. Substitute all the values, do the simplification, so that a variance of v is a 7.1032. All right. So take these three problems as assignment problems. Here u and v are defined in terms of sin theta and cos theta, and we have said that x and y's are uncorrelated. As a result, covariance of x and y's are 0. For these values, calculate covariance of uv, theta, variance of x and variance of y. Repeat the problem for these values. Similarly, repeat the problem for these values. Let us take these three problems as an assignment problems. All right. Let us take the next problem. A zero mean bivariate random variables x1 and x2 have the following variances. Variance of x1 is 2, variance of x2 is 4. Their correlation coefficient is 0.8. Covariance of x1 and x2 is 0.8. Random variables y1 and y2 are obtained from y1 is equals to 3x1 plus 4x2, y2 is equals to minus x1 plus 2x2. Find the values of variance of y1, variance of y2 and covariance of y1 and y2. So to calculate variance of y1, variance of y2, covariance of y1 and x1, so covariance of x1 and x2, it is already given it as a 0.8. Covariance coefficient is already given as a 0.8 here. So we are in need of covariance of x1 and x2 that can be calculated using this formula. Using this formula, a covariance of x1 and x2 can be calculated here. It is given, these two values are given here. You can observe here variance of x1 is given, that is what, sigma x square. So sigma x1 can be calculated by taking square root of 2, then taking square root of 4. As a result, covariance of x1 and x2 is 2.2627. Alright, it is needed. This calculation is done because a covariance of x1 and x2 is needed in the calculation of a variance of y1, so that covariance of x1 and x1 and x2 is calculated here. Let us make use of this formula. So substitute all the values here. A is 3, B is 4, covariance of x1 and x2 is 2.26. Then do the simplification. We will get a variance of y1 is 136.29. Similarly, a variance of y2, use this formula where C and D are nothing but -192 respectively. Covariance of x1 and x2 is calculated. We know the variance of x2, variance of x1. Substitute all the values. To the simplification, we will get the value as 8.95. Covariance of y1 and y2 that can be calculated using this formula. A, B, C and D are the constant from these two equations. Substitute, do the simplification. We will get the result as 30.5254. Alright. Consider the next problem. A random variable x has a mean of 3.0 and variance of 0.7. The random variable y has a mean of -0.3 and the variance of 0.6. The covariance for x and y is 0.4666. Given the transformation, u is equals to 10x plus 6y, v is equals to 5x 13v. It is 13y. It is 13y. Calculate values for a variance of u, variance of v, covariance of u and v. Let us rewrite the given data here. A mean of x, it is mu x. Variance of x, it is sigma x square. Mean of y, variance of y. Covariance of xy, it is 0.666. So they have asked us to calculate a variance of u, variance of v, a covariance of u and v. Using this formula, variance of u that can be calculated using this formula, you can observe here all values are known here. A is known, it is 10. Variance of x is known, it is 0.7. Covariance of xy, it is, they have already given in the formula itself. The covariance, you can observe here, covariance, it is directly given instead of covariance covariance coefficient. Covariance coefficient instead of covariance coefficient, here the covariance is directly given, so that no need to calculate a covariance of x and y here. Substitute all the values, do the simplification, we will get that value as 147.525920. Similarly, variance of v that can be calculated from equation number 2, where 5 and 13 should be used in the place of c and d. Do the simplification, we will get 179.558. Then covariance of u and v. Using this formula, substitute all the values, do the simplification, results 156.4560. Alright. Consider a random variables u and v are related to x and y with u is equals to 2x minus 3y and v is equals to 4x plus 2y. And we know that a mean of x is 13, mean of y is minus 7, variance of x is 5, variance of y is 7, and covariance of x and y equals to 0. Then calculate variance of u, variance of v, and variance of u and v. Same problem, same procedure should be followed here. The meaning of this covariance of xy equals to 0 means their x and y's are uncorrelated. Rewrite the given data. Of variance of u can be calculated using this formula. Substitute all the values here. Answer is 74. Variance of v, substitute all the data, do the simplification. Answer is 104. Covariance of u and v, substitute all the values, do the simplification, make use of a calculator properly, so that answer is minus 76. Alright, so we have completed bivariate transformations concept completely. So in the next video we do study a Gaussian bivariate random variables. If you have any doubts means you can ask me at any time, and feel free to ask your doubts, and like, share, comment on the video, and don't forget to subscribe the channel. We see in the next video. Thank you.